So, a relativist admits that mass does not increase with velocity. I'm going to give a quote from a relativist admitting that he had been wrong about mass increase and that mass does not increase with speed or velocity. A straightforward interpretation of such a quote would mean special relativity is wrong and that Newtonian physics was correct all along. But context is important, and when we look at the context we find that he is talking within a context of nonsense. Some relativists have noticed that talking about mass increase with speed or velocity is problematic, so they have decided they don't want to talk about mass increase anymore if they can help it. They don't want to abandon special relativity, so they try to play around with the words and bluff things off. And these are the main places I'm going to. The link is Proving Special Relativity episode 1, Proving Special Relativity episode 2, and the main person talking about this is a Don Lincoln. So first of all I'm going to show you the quote. So the quote is, "Relativity also says that energy and mass are essentially equivalent. The phenomenon of gaining higher velocities by adding energy to a particle is often explained as mass increases as things go faster." I admit I have uttered those words myself, but the statement is actually wrong and so can be misleading. So he's admitting he made a mistake. Mass increases as things go faster. He's admitting that he said that in the past and now that is a mistake. And this is how the relativists like to change what they're saying and say something else later on. So if we look at him, here's the person at Wiki. Don Lincoln, he's the person who's written this. He's an American particle physicist, a researcher at Fermi National Accelerator Lab, and so forth. Has a few talks on the internet, I think. So that's the person. And we go to the first one. This is the first episode 1 of what he's talking about, and it carries on to episode 2. So my name here, Don Lincoln. So this is what we're going to start with. We're going to go through this and get to his quote. As I say, he's talking within a context of nonsense. So even though he might initially sound like he's making sense, if we just quoted that quote, he doesn't make any sense whatsoever. So here we go. More than 100 years after Einstein penned his theory of special relativity, the internet is full of people who question his ideas. Yet particle accelerators such as Fermilab's Tetratron and CERN's Large Hadron Collider simply wouldn't work the way they do if Einstein was wrong. So he's making that claim, and I think that's false. If we go to my videos, find them again. Videos there. I've gone into details about the mathematics, and the main thing which Einstein does is a cuckoo process. Einstein deals with some maths and it's not really clear what he's doing with that maths, and so if they're going by Einstein's relativity, then it's just connecting very weird nonsensical maths to lab experiments. So I disagree with him on that point. He's saying it wouldn't work, but it sounds very much like he hasn't really paid attention to the nonsense which is behind the math which Einstein is dealing with. So we continue. We can go down a bit. In 1905, Albert Einstein wrote 4 seminal papers. The most famous was the theory of special relativity, which describes how an object behaves as its speed increases. It predicts the most mind-bending things. Time slows down as speed goes up. Increase in speed also causes the length of an object to shrink. And according to some science popularizations, an object's mass increases as its velocity approaches the speed of light. So that's the sort of thing he's saying. And if we can go back to a bit, yeah, weird things happen as its speed increases. Yep. Weird things happen according to special relativity, and from my point of view, it's all just a mess. Mind-bending things. Yes, mind-bending things, and that's indicated it's nonsense. Time slows down, speed goes up, and I've dealt with that in another video, that when these people who believe in Einstein's relativity, they do have conflict, they do say things wrong, and I gave into this one here. Brian Cox, you've got to be careful when you talk about time. You can talk about it incorrectly, and there's a conflict here between what Professor Brian Cox is saying and another relativist who's talking about time, and you've got to go into details about the frame of reference. So simply just saying time slows down, that can give completely the wrong impression of what's really going on. Time slows down as speed goes up. Really, you need to talk about a frame of reference. So you've got that problem. I haven't gone into the issue of increasing speed causes the length of an object to shrink. When you actually look into that, there's no experiment that actually does show that. It's only inferred. So it's another little bit of nonsense there. Right then. So here we go. And according to some science popularizations, an object's mass increases as its velocity approaches the speed of light. And so what he says about that is, this statement is both kind of sort of right and terribly wrong. We'll get to that in a future column. So at this point in episode 1, he's saying it's sort of right and terribly wrong. Later he's going to say it's wrong. So he's kind of muddling things up here. And that's typical of what the relativists do. They do muddle things up. They have words and they want to muddle those little words up. Kind of sort of right and terribly wrong. That's just muddling around with the words. So I'll move this down a bit more. Perhaps its best known prediction, that's special relativity, is that no object with mass can go faster than light. This last statement is especially disappointing as it puts the kibosh on mankind's dream of zipping around the galaxy and exploring nearby stars. Well, even if you do believe that about special relativity, it doesn't really limit interstellar space travel. It might make it a bit difficult, but you could go around, travelling around the universe at speeds slower than the speed of light. Maybe you could get up to 1/10 the speed of light, so that would still be quite a good speed to get around. So something 4 light years away at 1/10 the speed of light, that would be about 40 years, I think. So still quite good. Right, going on to the next bit. These predictions are all counterintuitive, and he's talking about special relativity, and being counterintuitive, you should be really thinking, well, this theory doesn't make any sense, this theory is nonsense. We never see these behaviours in our daily lives. If you're in a high-speed jet fighter, the length of objects don't shrink. Well, according to special relativity they do, but it's a very small effect. Objects themselves don't get heavier, and time seems to march along at its familiar pace. Well, he's going to object about things getting heavier and time is, well, if you were on time, it would be supposed to be a small effect according to special relativity. This getting heavier is going to be a problem in a minute. Right. The fact that Einstein's predictions and common sense disagrees prompts a subset of science enthusiasts to react against the theory of special relativity, the theory of relativity, correct? So, violates common sense, yes. And not only does it violate common sense, it doesn't make any sense whatsoever, Einstein's special relativity. What you get is people who believe in Einstein's relativity, and they all start making contradictory claims about it, and so it leads to utter confusion. So they're just talking nonsense, these people who believe in it, and that's my main take on it. If they were consistent in what they were saying about special relativity and general relativity and so forth, then it would probably start to make a bit more sense, but it doesn't. They all say contradictory things. Science bulletin boards are full of relativity deniers, some holding firmly to the ideas of the 1800s, and others espousing ideas that are alternatives to special relativity. Well, yes, I think 1800s is quite a lot better, depends what you're reading. When you get to Einstein, things get really messed up, and it's not a question of really being a relativity denier. I actually do go by relativity. It's just I say what Einstein did is messed up, and if you do actually look at relativity issues in the 1800s, then things do sort of make more sense. And so when it comes to espousing ideas that are alternatives to special relativity, well, really, special relativity is a collection of messed up things. And if you look at it in a certain way, maybe it does make sense, but with all the people making contradictory claims, it just comes out as nonsense. Plus, I think it should be pointed out that what Einstein said about special relativity, which is supposed to be his theory, it doesn't really make sense. If you look at other people, maybe what they're saying makes more sense. Say if you're looking at Poincaré or Lorentz, then what they were saying, which is their theory, it probably makes more sense. It's just what Einstein's saying makes nonsense. Now, part of the gap between ordinary experience and Einstein's predictions originates in the velocities involved. Until you get to really fast speeds, special relativity is numerically indistinguishable from the classical physics you learn in high school or freshman college class. So, well, that's a claim, but when you actually look into the maths of that, well, it doesn't really make that much sense. In fact, the difference in physics between the two approaches is less than 1% until you get to a speed of 18,600 miles per second. I think that speed he's got wrong. It's probably, I think he might be missing a naught there. But anyway, I think I should look it up. Speed of light. So speed of light is that meters per second, isn't it? Yeah, so no, speed of light, it's difficult to, it's there. According to there, it's that 186,000 miles per second. So light travels at a constant finite speed of 186,000 miles per second. So he's missed that at 0 probably. But anyway, so what it carries on then. That's about fast enough to get from Chicago to Honolulu in a second, and not even going the short way. That's going via London. So he's been making jokes here. Given that an M16 rifle bullet barrel travels through the air at about half a mile per second and that the fastest projectile ever fired moves at about 10 miles per second, it is not surprising that your intuition doesn't accurately predict the behaviour of matter under these super high speeds. So, really, what you're doing at low speeds, if physics, the laws of physics were consistent, then that should really apply to high speeds as well, but he's deciding to believe otherwise. So it's another flaw in his thinking. The question comes, if things work out in a certain way in low speeds, why shouldn't they do the same for whatever speed? Over the next 3 columns we'll talk about relativity, with an emphasis on how particle and accelerator physics demonstrates without any doubt that Einstein's ideas are correct, and I disagree with that. But unfortunately I haven't got the 3 columns, I've only got 2. So I'm only going by what's on 2 columns. While you have to wait for a subsequent column to learn about some detailed evidence, I can tease you with a compelling demonstration of why scientists don't use classical physics when they design accelerators. Let us use the venerable Fermilab tetratron as our example. This accelerator was a ring 3.9 miles in circumference. According to relativity, the protons in the accelerator moved at 99.% the speed of light, or 186,000 miles per second. So he's got the speed right this time. He didn't have it right earlier. Right. So what's going to do with those numbers? Given these figures, relativity predicts that the protons will circle the ring about 48,000 times a second. In contrast, classical physics predicts that the velocity of protons in the tetratron is about 46 times faster than light, and therefore that a proton will orbit the ring about 2,220,000 times a second. Fermilab accelerator scientists observed the expected 48,000 times a second, score 1 for relativity. So I think he's wrong again. He's thinking score 1 for relativity, but when we go on to that, it's going by the maths which they've created from believing special relativity, and really that is a sort of corruption of the maths which you would use in Newtonian physics. If we go here, that one. The maths it's built up to be used in special relativity is nonsense. It's this doesn't make any sense whatsoever. So making that claim doesn't really follow. It's sort of they got to maths, they got it from believing certain things from Einstein, and so it's only relevant that they're then interpreting it from that. They're interpreting from their special relativity that it's 48,000 times a second, based upon the maths that they built up from believing in the speed of light constant and all the other things. And if you go into the speed of light constant, well, really that's based on a lie. And I pointed out about my first one, the lie on which Einstein's relativity is built. They couldn't actually measure the speed of light to be constant, and so they had to define it as constant. So when they go in to do the maths for special relativity, it's only what they built up from having defined the speed of light as constant. And so if that definition is incorrect, but they shouldn't have used it, then all these other maths which they've got from it is wrong as well. So in the next column we'll look at the energies and velocities and the various accelerators in the Fermilab complex and explore the idea of relativistic mass. Given the ability of scientists at accelerator laboratories to accelerate particles at high velocity, we are able to confront both classical and relativistic physics with real data. The message from the data is clear: our universe obeys the law of relativity, and if he means special relativity then he's wrong. Special relativity is just messed up mass. And so as I say, it's this person, Don Lincoln. So I go on to the next one. episode 2. This is episode 2 of Proven Special Relativity. Got the old Einstein there. You'll need to reduce it a bit because it's... Here we go. Carrying on. In my last column, I described some of the recurring questions raised by people sceptical about whether Einstein's theory of special relativity accurately describes the motion of objects travelling close to the speed of light. A particle accelerator is an environment in which very high velocities are commonplace, so we can use the experience of successfully running the tetrotron for more than a quarter century to address the question. Prior to the shutdown of the tetrotron in 2011, the Fermilab accelerator complex consisted of 5 accelerators, much like the gears on a car with a manual transmission. Each accelerator added some energy to a proton until it reached the tetrotron's maximum energy of 1 trillion electron volts. At that energy, the proton travels with a velocity 99.% is the speed of light, which is 160,000 miles per second. To give some perspective, a proton travelling at that speed could circle the Earth's equator almost 8 times in a single second. So he's going on to carry on. In the table below, we see the maximum energy each of the 5 accelerators can achieve and the velocity that protons at this energy are observed to travel. When protons reach this booster, they are travelling at very nearly the speed of light, even when they were in the tetrotron, which provided 125 times more energy. Their velocity was only a tiny bit faster. Even the LHC, Large Hadron Collider, with the maximum velocity, maximum energy 7 times higher than that of the tetrotron, only makes protons make an iffy bit faster than the tetrotron. And these are the figures he's given. And with all these sort of numbers, it's all still based upon messed up maths from Einstein's relativity. So as I pointed out in the got the light upon what the maths is built upon, and when we go to the maths, look at the maths they're using. It's nonsense. Where is the maths? Go to the maths, fine. When the math is being dealt with, it's just nonsense, basically. So really, they're just taking some maths and they're fixing their experiments to conform to that maths. So it doesn't really mean anything. If you tidy up the maths, then you could get the experiments to agree to a better set of maths. Anyway, he then gives his interpretation of that. These measurements demonstrate that the velocities of particles' mass do not exceed the speed of light, no matter how much energy we give them. This upholds the theory of relativity, presumably means special relativity again, which says that nothing exceeds the speed of light. And it's all just really a bodge to the mass, because you're defining the speed of light as constant, and then it's a knock-on effect from that. Carrying on. Relativity also says that energy and mass are essentially equivalent. That was the bit. And this is the bit that he's admitting that he was wrong. He's admitting he's wrong in this bit. Relativity also says that energy and mass are essentially equivalent. The phenomena of gaining higher velocities by adding energy to particles is often explained as mass increases as time goes faster. I admit I have uttered these words myself, but the statement is actually wrong and so can be misleading. So he's admitting he's wrong now, and earlier he had a little bit of a bluff when he was dealing with that. When we go back to the quote. So he was then saying about that sort of statement. This statement is both kind of sort of right and terribly wrong. We'll get to that in a future column, and that's this future column. In this future column he's just suddenly saying it's wrong. Before it was It was a little bluff of words. So getting on to this, we're seeing the context of what he's saying now. It's all this nonsense. For instance, some people hear the words mass increases and think that particles are getting heavier in the gravitational sense. In fact, it is more accurate to say that inertia increases as velocity increases. At low velocities or non-relativistic velocities, it is perfectly reasonable to equate inertia or mass. This is the reason even scientists sometimes say that mass changes with velocity. They use the phrase relativistic mass to label this fallacious idea of increasing mass. What? It's just nonsense now. We suddenly hit the nonsense, complete and utter nonsense now. Mass increase. Yeah, if mass increases, then they should be getting heavier. Yeah, in the gravitational sense. Yeah, because with mass, if you've got an object, it's got mass. You drop it in the Earth's gravity field, then that's it. It's attracted to the Earth. Yes, gravity attracts mass, and if your object has more mass, then it's heavier. Yeah. The more mass an object has, the heavier it is. So people hear the word mass increase. Yeah. That means it gets heavier. Yeah. Yeah, that's right. So next one. In fact, it's more accurate to say that inertia increases as velocity increases. What? Inertia. If we go to inertia, I've got a link to say what that means. Inertia is the resistance of any physical object to any change in its state of motion, including changes to its speed and direction. It is the tendency of objects to keep moving in a straight line at constant velocity. So what you've got is, if you've got an object, it's got mass, and the more mass it's got, the more inertia it has, and the more resistance it has to that object be given motion. So what you have is, you could talk about inertial mass, and in that case you've got inertial mass, yeah, and you've also got gravitational mass. So if we're going by Newton, inertial mass and gravitational mass should be the same. So what's he saying? Is he saying now that inertial mass is not the same as gravitational mass? He's not being clear here. He's just bluffing it here. It's more accurate to say that inertia increases as velocity increases. So what you mean? Inertial mass is increasing as velocity increases. But shouldn't that be the same as saying that gravitational mass is increasing? He's not being clear. It's just bluff. It doesn't mean anything to suddenly say inertia increases as velocity increases, instead of saying what's commonly said, mass increases as velocity increases. It's just nonsense. He's just nonsense. He's not explaining himself at all. And that is just typical of what the things these relativists like to do. So we had a very clear statement here that he was wrong in saying that mass increases things go faster, and he admitted he was wrong. But what's he saying now? It's just nonsense. Going on to the next bit. At lower velocities or non-relativistic velocities, it's perfectly reasonable to equate inertial and mass. So what does that mean? He means equate inertial mass and gravitational mass. He probably means that. And that would be Newtonian physics. This is the reason even scientists sometimes say that mass changes with velocity. They use the phrase relativistic mass to label this fallacious idea of increasing mass. So it's a false idea now. Fallacious means false, doesn't it? Mistaken belief. Fallacious is mistaken belief. It's false. What's he talking about? He's gone off the rails now. Inertial mass. You equate inertial mass. We mean equate inertial mass and gravitational mass. and that would be Newtonian physics, and that would be at low velocities. So at low velocities we're going by Newtonian physics, and then an increase in inertial mass would be the same as an increase in gravitational mass, isn't it? He's not clear. He's not making it clear at all. What's he talking about? He's just talking nonsense. This is the reason even scientists sometimes say that mass changes with velocity. They use the phrase relativistic mass to label this fallacious idea of increasing mass. So it's a false idea of increasing mass. But how much of it's false? Is it relativistic mass? Is that false as well? An object's got relativistic. If an object's got relativistic mass, is that a false idea? Is that relativistic mass? Is that supposed to be gravitational mass? Or is it only inertial mass? He's just talking nonsense. It's just nonsense. You could carry on. You're just going to talk more nonsense. In fact, there's only one mass. What? One mass? We've got relativistic mass, and we've got inertial mass, and we've got gravitational mass, and now he's saying there's only one mass. He's just gone balmy, and that is often called rest mass. So we've got a fourth type of mass now, which is the mass of an object when it is not moving. What? If I'm standing here, I need to talk about if I'm standing here and I'm not moving, then relative to me, if I have an object which is also not moving, then I could say that has rest mass. So in my frame, but that's only because I'm not moving. But somebody else who could be looking at me could be saying, oh, I'm moving, and the object I'm talking about having rest mass is an object which is moving. When you're talking about something about having mass, you need to talk about it relative to a frame. So when it's not moving relative to who? The theory is special relativity. It's about relativity. Who's moving? It's not moving. Who? What frame is that? It's just nonsense. He's just gone off the deep end. Even though the idea of relativistic mass is strictly speaking not correct, it is a valuable mental picture and helps us get used to the fact that objects cannot exceed the speed of light. So, even though the idea is wrong, he's calling it fallacious earlier. It's a fallacious idea. It's wrong. Even though it's wrong, it's helpful. What? It's nonsense. Just nonsense. What are you talking about? You're talking out of the wrong orifice. So if you prefer to think about relativistic mass, go ahead and do so without feeling guilty. Guilty? You're talking nonsense. You told us 1 minute now that mass doesn't increase. What are you talking about? Just realise that if you push the eye too hard, it will lead you astray. Well, it's led you astray because you're talking nonsense now. So, we're now back to the relativity skeptics. Some relativity skeptics are aware that laboratories such as Fermilab and CERN have demonstrated that the speed of light is a limitation in particle accelerators. Well, if you go back to the maths, which I'm looking at for these things, which I've highlighted in my videos, then really it's all just a cuckoo process. They've built up some maths, and it's as pointed out from here, it's a cuckoo process creating that maths, and if you then making your experiments conform to that math, and it's not really making that much sense. So you haven't demonstrated anything. All you've got is some funny maths. Right. So they have an incorrect explanation that goes like this. Particle accelerators use electric fields to impart a force on, say, a proton. So it's the electromagnetic field, it's the electric field and the magnetic field, and they're acting upon these particles in the accelerator. These electric fields, which accelerators use to propel the protons, are composed of photons. Photons are the particles of the electromagnetic field. According to the theory of quantum electrodynamics, so we're wandering off now a bit from relativity, aren't we? Thus they reason particle accelerators shoot photons at protons, and if a proton travelled faster than a photon, it would no longer feel the photon's force. They claim this is the reason that protons can travel no faster than light. Well, it's wandering off from relativity, and already we've got here, from this little paragraph here, it's just utter nonsense which he's been talking here. So how do we go from utter nonsense to sort out something like that? But he carries on. This reasoning does not explain how the tiny difference in the proton speed between the Fermilab booster and the tetrahedron results in the beam's energy increasing by 125 times. So the explanation is wrong. Well, whatever. He just carries on that little bit. It doesn't make any sense at this paragraph here. It just doesn't make any sense, that paragraph there. So how do you carry on with these paragraphs? It's just nonsense. And that is the sort of like typical trick the relativists do. He's decided this idea of mass increase is a problem. If we go back to here, relativity also says that energy and mass are essentially equivalent. The phenomena gaining higher velocities by adding energy to particles often explained as mass increases as things go faster. I admit I've uttered those words myself, but the statement is actually wrong, and so can be misleading. So he's admitting now that that is wrong, and the way he gets out of that, because he still wants to believe in special relativity, is he just plays around with the words, and the words he's using are just nonsense now. You're not explaining what he's talking about. If we go here, this is actually the equation for it. So we have here the relativistic mass equation, and then this side they're still talking about relativistic mass increase. So it's mass increase, and that's the relativistic mass there, and that's the rest mass there, and this is dimensionless ratio. So V squared over C squared, and that's got no. It's just about it comes to dimensionless ratio. So this is just a number. So that mass equals another mass times a number. That's a mass. That's mass, and that's mass. That's called relativistic mass, and that's called rest mass. So if this is mass, if that mass is increasing, is it being affected by gravity or not? What's he talking about in this last in here? What's this Don? If we go to him, Don Lincoln, what's he talking about? He's not explained himself very well at all. He's just fallen over the words. If we go to, this is Wikipedia upon it, and it's got, this is Wikipedia, it says there's controversy. Ockham and followers reject the concept of relativistic mass. Also Arnold B. Arons has argued against teaching the concept of relativistic mass. So for many years it was conventional to enter the discussion of dynamics through derivation of the relativistic mass, that is the mass velocity relation, and this is probably still the dominant mode in textbooks. So most books, according to this, textbooks on relativity are still talking about mass increase with velocity. More recently, however, it has become increasingly recognised that relativist mass is a troublesome and dubious concept. So if you go into here, it doesn't make anything any clearer. It's still what the hell they're talking about. They've sort of been teaching for a long time that relativistic mass of an object increases, that meaning mass of an object increases with velocity, and now suddenly they've worked out that that is a problem. It doesn't really make sense. And so what do when they're faced with something that doesn't make sense? They decide, well, they've said it wrong. Mass increases as things go faster. I admit I have uttered those words myself, but the statement is actually wrong, and so can be misleading. So they worked out that that doesn't make sense. Saying that doesn't make any sense. And so what do then? They fumble over the words, and the words still don't make any sense. They want to stay with relativity, special relativity, and they just want to then fumble over the words and not make any sense whatsoever. They're talking about something here. Got loads of different types of mass. You've got relativistic mass, you've got inertial mass, you've got gravitational mass, you've got rest mass. Well, how are they supposed to be related? What's going on? It's just nonsense. They haven't explained themselves at all. It will lead you astray. Just realise that if you push the ideal too hard, it will lead you astray. Well, this is basically what is wrong with Einstein's special relativity. It's just all nonsense. You look at it, if I go to my videos, it's a cuckoo process. It doesn't make any sense. So if you do push anything too hard in special relativity, you end up with more and more nonsense. That's why you've got that problem. That's why you're going to get led astray. But people like you, Don Lincoln, you're not going to accept that. You're just going to stick with it, and you're just going to mess up the words and carry on believing your things, and you're going to mess up the maths and so forth, and you're just going to carry on believing your cuckoo process. Thank you. That's the end.